Okay, so NumPy has several data types. Of those, these are the ones that we'll be using. Now we have two data types for integer, so int32 and int64. The difference is the amount of memory that you need. So int64 will use 64 bits for each number. So if you don't need 64 bits for the data that you're going to be dealing with, you use int32, which will require less amount of memory to hold your data. And that's more efficient. So you have two choices, int32 or int64. And same for floating point. Floating point again, okay, you have 32 and 64. I think for floating point you also have 16. But anyway, so these are not this is not an exhaustive list of all possible data types. And these are the data types that we will normally be using. So floating point you have two, and then we have Boolean. Boolean is just true or false. Okay, the numbers 1 or 0. And Python codes all positive values as Boolean true and all 0 non-positive, that is 0 and negative values, as false. Okay, and sometimes it's convenient to use this bool function to count how many values are positive, how many values are non-positive, and that kind of stuff. And then Unicode, okay, it's probably better to, this is good, Unicode, and you can specify the number of bytes that you need for the string. But you can also use just simply str. Okay. So str is the Python data type. So you don't have to, for the ones above str, you have to prefix as np, np dot int32 or np dot float64. But you don't have to do that for str, because str is base Python data type. Okay. Now, NumPy will automatically detect what data type the data, all the data that you provided can coexist in. So if all of them are integer, then NumPy will automatically select integer, either 32 or 64, as in 32 normally, as the data type. But in that data, if you have a floating point value anywhere, then for the floating point value to coexist with the rest of them, NumPy will automatically detect floating point as the data type. And then if it has a string, then again, everything will be changed to string. Remember, NumPy arrays, okay, you can have n dimensions, but they are all the same data type. You cannot mix data type in NumPy arrays. Okay. Now you can set data type. Okay, like here is an example of NumPy type coercion. Type coercion is what I just was telling you about. So if these are the numbers, you don't have to specify the data type, right? And I have to run NumPy first. Okay. Okay, so NumPy type coercion is that the L2 is coerced into integer automatically. If L2 has a floating point, so when you have a number and then a decimal place, even if you don't specify a value after the decimal place, the number is taken as a decimal value, then the data type is coerced into floating point. Okay. Now, if one of the numbers is coded as a string, then the whole thing will be coded as string. So it is important to understand these concepts, because when you bring in data from external sources, the data columns may be contaminated in some of these ways. You may have you may expect numbers, but NumPy will read it as a string. And you may be wondering, why is it reading the column as a string? It's because there is somewhere down the column there is a value that is coded as a string. So you have to change that, convert that. So if it is this, then the data type is Unicode, which is another way of saying it's a string. Okay? Now you can set data type in two ways. You can use the dtype attribute with the np.array function. So remember, np.array is the function that we use to set up a NumPy array. So you can add the dtype attribute. Okay. So like you have here, okay, now let's take that one. Okay, so now we say dtype equal to np int32. Okay. So now you see that even though we had a decimal value, a floating point value, okay, you're not letting NumPy automatically set the data type for you. You are setting the data type. Of course, if the data type you're trying to set is incompatible with the values you have, you will have an error. So for example, so here this was a floating point value. So it's easy enough to change that to an integer value. But instead, suppose if you had an A like that, and then you specify dtype is np int32. That will throw an error, because NumPy cannot change A into a numerical value. Okay? So you can use dtype equal to any one of these types that I started out with. Okay? As long as it's compatible with the values that you're providing, the dtype will work. Now, if you already have a NumPy array, so the dtype is what you use when you're creating a NumPy array. From a list, you create an array, and then at that point in time, you can specify the data type you want to use with a dtype attribute. But if you already have a NumPy array, then and you want to change the data type, right? So, for example, we have that. Okay, and let's say that we created the data type, we created the NumPy array, letting NumPy set the data type automatically. Right? Now, you want to change that to an integer data type. Okay, it's coming in as floating point. It's already created. So now we can say NPARR7 as type, and then specify the data type you want. Okay, so now it's changed to integer. Okay, but when you do it this way, it is not permanent. Okay, it just changes, but it doesn't change it permanently. So NPARR7 is still floating point, even though it changed, but it was not saved. So if you want to save it, then you have to set it equal to itself or a different name variable. If you do that, then you see it's permanently changed.